Okay, that's great. Um, Hello everybody, I am Monsieur. Today, I have made another Panda3D program that I would like to share with you. This program goes over the task or the idea of how do I make a camera rotate to look at something, or how do I set up input so a camera will move according to what direction I'm facing, while using the mouse to look around like you would in a first-person game. So um, there's a bit of stuff going on here. So I would like to try to make this as straightforward as possible, and let's start taking a look at it. The idea that I kind of came up with while making this program is something I got from somebody else's idea on the Panda3D forums, and this code is something that I changed based on some code that I read from their forum post. So there are a few variables in this program that are important, and there are some things that surprised me while I was making this. I grouped all of the simple variables together that I think I would be using inside of the show base, or the main kind of entry point to a Panda application. Showbase is this big kind of idea that has a lot of features and allows you to get input and allows you to store things in it, and using that, I access its variables throughout the program, and I store these player variables inside of the application. So the method I use to figure out which way I want something to face is using this concept called a quaternion, or a quaternarian. I don't know. Turns out the process for calculating the angle for something to be facing something else, or to be facing something else, is quite complicated. However, by using these built-in functions in Panda, I was able to make it quite simple, or at least simple enough that I didn't need to understand the math behind it, which I like. So the important code to be able to find where I want something to face in the 3D environment is finding the difference between positions of the direction you want something to look at, or the position you want something to look at, and the position that something is already in. I guess it's a little bit too. I guess it would make sense to question why you wouldn't use angles in this context to, like, say, well, how is it going to know which direction to rotate if I'm using positions and not actual angles? But the interesting thing about this is um, hold on. Okay. Um, my headphone was my headset was becoming disconnected from this wire I have it connected to. So the different positions here find this position that this look-at function uses for quad2, which is the quaternion object that's going to be important for finding the angle between two things. When I use this look-at function, storing the result of whatever look-at does, or the calculation of the angle between these two points, doesn't actually perform an action on anything in the 3D space, but it gives me the 3D angle that I want to use later. So it stores it inside of this quad2 variable after it calculates what the angle is. And in this program, I take the idea of I take the idea that the person who wrote the code I based this off of used as their idea, which was to reparent the default camera to a new node, and then use that node to rotate the camera. So let's take a look at how the camera kind of works. Here this function is a Panda3D task that's called by the task manager, and the idea is that every time this is called, the pointer is moved to the middle of the screen, and this function, which uses base, which is the show base global variable that's in every Panda3D program that uses show base, I believe. The move pointer function moves something to a specific point on the screen. So by getting the size of the screen and dividing it by 2, I can get wherever the center is on the x-axis, and then I can do the same for the y-axis. And these are like absolute values, and they aren't relative to anything. However, The mouse X and mouse Y variables are relative, or are values between -1 and 1, being the -1 being the left-hand side of the screen, and 1 being the right-hand side. Something I found out while I was making this is that Panda actually has a rotation system, which I apparently didn't really think about while I was making these programs before. When you rotate something or set a heading for something, the positive direction is actually to the left. So in order for this to work, I need to reverse the direction of the mouse X. So that when the mouse is on the left side of the screen, I'd be setting a heading with a positive value instead of the negative value. And I set up the heading and pitch that I want to use by just multiplying the percentages that the mouse X and mouse Y represent of where the mouse is on the screen by any number that I would want to be the sensitivity for how much I want something to move. So depending on where it is on the screen, it will move up to 10 degrees when this heading and pitch are set for the camera. And then that is how the camera aiming with the mouse works. So let's take a look at that. Here I just loaded a model that I used in the basketball Arkham Up math video. So moving left moves the camera to the left, and moving right moves it to the right, and up and down don't need to be changed, I guess. Hello again, and hello to Windows giving me a great ability to find and replace things. I guess we're back after that commercial break. Exiting out of the program, stopped my recording as well. So that's fun. I think I was recording for about 6 more minutes before I realized. So let's continue where I believe we were, or where I believe I was. This is all that I use to be able to move the camera with the mouse. So let's take a look at the rest of the program. The code that I use for setting the camera up is on these lines where I use this effect setting function that I don't completely understand, and I reparent something to the node path I use to rotate things, and then this lookat function is something that I don't really know if it's completely necessary, but looking at having the camera look at the node path that I'm using might align things in some way. I saw this in the code that I based this program off of, or what I used as something to try to figure out what I was doing. But because the camera movement I have set up is moving something or setting the heading relative to where it was before, I don't know if this is going to do anything when I'm moving something relatively. So this is all the code here is what I use to set up the basic camera structure that I use. And let's take a look at the other function that's I made in this program, which is this one called rotate placement. I look at that, it's this section of the code that I'm just looking at my time again, like hoping that I didn't accidentally stop recording for a twice time. I was explaining before that this area of the code is something that I use because I didn't want something to keep rotating if it continued to have the same heading or rotation that it did before, because to me that would make it seem like a model isn't rotating because something is conflicting with the rotation that's being set on it. So the code here is my basic idea of if something has not been rotating for some time, then stop executing the task. But the rest of the code is related to rotating something at a specific speed towards the angle that I calculated in the quaternion that I'm using. So to be able to rotate, to be able to have a model rotate to the direction or a different position that you specify, I use the quaternion's rotation and then subtract the heading or the rotation that the model has. Sorry. Seems like I'm having headset problems. I don't think this is plugged in very well. Sorry about that. So depending on if the difference between the two headings is positive or negative, if it's positive, then I can get the minimum distance between the headings or the speed that I'm using. And whichever one of these is smaller is what I want to use for rotating in this task. Since tasks are executed a lot, the numbers that I'm using here are the speed that I'm going to rotate this every frame, basically. So when the distance between two headings is greater than the speed that I want to move at, then I just use the speed. And to differentiate between the two numbers that I use the direction to say, well, if it's positive, that means it's going to be moving left, because I believe I said before, objects that have a leftwards heading are moving in a positive direction in Panda. So since this direction I figure out is greater than 0, if it is, I find the number that I want and then move it counterclockwise. And then if the angle is negative, I believe, then I just use a negative number. But I also had to switch the quaternions rotation and the model's rotation here, because I'm still using this min function for finding the distance between both of these situations. So that's cool. And I believe both of these values will be negative, so that means that this situation sets the heading to be clockwise, or a negative heading in Panda. And then here's another unnecessary part of the function that I like, but I like it because even though the rest of the function should work, it's cool to have something that works based on context. So if another function was setting the rotation in some way, then this task would return saying if the rotation is already facing the rotation of the quaternion that I'm calculating. So the model would already be facing the quaternion rotation. So then after that, I set the heading, and I set it relative to itself, so I don't have to perform additional calculations of where the heading is and what I would need to calculate to have an absolute heading. And that's how I get this thing to rotate to a specific position. So let's take a look at that. Maybe I should remove these. I don't think these are being used in this function. Also, something to note here is not to run both of these tasks at the same time if you're looking at this program. Both of these tasks use data of like setting rotation. I believe the I'm not sure, but I know running both of these at the same time uses data that's being used in both functions, so it ends up looking kind of crazy. Maybe I fixed that. That doesn't seem right. Oh, right. This line is what has both of these functions using similar or the same data. So running this should have things act crazy. Actually, fair warning. Sorry, I should have said this before. If you don't want to look at rapidly rotating things, you probably shouldn't look at that. Sorry about that. So let's just take a look at what it looks like for something to rotate to a specific angle using the code that I have. Let's run this again. I think I will rotate this at a slower speed so you can see what's happening. See, the model is rotating to face the direction that I specified. Fair warning, I suppose. I'm not entirely sure if I got all of this program correct, but I hope most of this is helpful. It is possible that the code I'm writing might have something facing the opposite direction of where it should be facing, but was that when I was making this, it seemed to make sense. So I hope it's helpful. Another part of this program, which is relating to the camera, is the zooming in and out function I have here. That's not too difficult to use. You could probably set up being able to move a lot of things in Panda, just maybe with like one line of code or between 1 and like 5 lines. Here I just use the inputs of being able to scroll something up and scroll something down, and then I call an event whenever that event happens. I call a function whenever that event happens. So this function sets the relative y position. This function sets the y position of the camera node that I added to the scene, and it sets it relative to itself. So whatever direction you're facing in will zoom in and out according to whatever rotation you currently have. And to be able to pass the arguments for the data you need to use, you can use this syntax when you're creating the event and pass whatever you're using, and whatever value you want to use, being in this example the speed that I want to move things at. Actually, no. This is the direction I want to move things in. 1 being zooming in and -1 being zooming out. The speed I have here is something that I set myself. But I believe that's a lot of what I've kind of made. So I hope you found this video useful. Thank you for watching, and I hope you will enjoy more videos that I have coming in the future. Thank you. Monsieur, we'll see you later.